Two-tailed z-hypothesis test for a proportion. Suppose 2 years ago 78% of students in high schools in Kenton County were considered proficient based on standardized testing requirements. A parent wants to determine if a change occurred last year in the proficiency level of all Kenton County high school students. In a random sample of 500 students in Kenton County, it's found that 372 were labeled as proficient. Using a 5% level of significance, has a change occurred in the proportion of proficient high school students in the county? We begin with the parameter P representing the proportion of all Kenton County high school students who were proficient last year. So this is what we're going to be testing and making an inference about. Now under the null, we say there really hasn't been a change. Okay, whatever was the case 2 years ago is what is the case last year. So for the null hypothesis, we say that parameter P is still the same thing. It is still that 78% level. So P is 0.78. Under the alternative, we want to know if there's been a change. Now a change means the number is not 0.78 now. That means it could have gone down or it could have gone up. In this case, we're looking for either change. So the alternative hypothesis, H sub A, is P is not equal to 0.78. Next, we let alpha be 0.05. That's our 5% significance level. So the decision rule would be written as follows. If the p-value is less than or equal to 0.05, then reject the null hypothesis. Next comes the test statistic. Our z-score, remember, is that formula, the sample proportion p hat minus the value of our parameter p, if the null is true, over the square root of p times 1 minus p over n. That equals p hat minus 0.78 divided by the square root of 0.78 times 1 minus 0.78, which is 0.22, divided by the sample size, which was 500. So multiplying all that out, taking the square root, I would get p hat minus 0.78 in the numerator, and the denominator is 0.018526. Adding the information from the sample, 372 divided by 500 is 0.744, minus 0.78 is the numerator of negative 0.036, divided by that denominator gives me the z-score of negative 1.94. Next comes the probability. Now remember, the alternative is looking for a change or a difference in either direction. As a result, when I find my probability, I'm going to find the area to the left of the negative version of what I calculated for my test statistic, plus the area to the right of the positive version. So I would mark off negative 1.94 and find the area to the left of it, plus positive 1.94 and the area to the right of it, and put those two together. In doing that, I really am just doubling the area to the left of negative 1.94. You can think of it that way. So if I find the area to the left of z equal to negative 1.94, in my table that is 0.0262, so I double that because remember the standard normal curve is symmetric about 0. So the area on the left side is going to be equivalent to the area on the right side. So I'm adding those together or multiplying by 2, and my probability is 0.0524. Next, I want to make my decision. Is the p-value 0.0524, is that less than 0.05? Well, it's close, but it's not less than or equal to 0.05. So the decision is going to be fail to reject the null hypothesis. In summary, I would say at a 0.05 level of significance, there is not significant evidence that the percentage of all students in high schools in Kenton County who were considered proficient based on standardized testing requirements last year is different than 78%. Last, let's check the validity. So in this case, is it valid? Okay, well, a random sample was taken and the collected data is categorical, right? Was the student proficient or not? N times P, remember the sample size was 500 times 0.78 gives you 390, and that number needs to be 10 or larger, which it is. N times 1 minus P is 500 times 1 minus 0.78 or 0.22. That is 110. That number needs to be 10 or larger, which it is. So the conditions are met. So the one sample z-test for a proportion is valid, or it is appropriate. So that concludes this example.